Most Fortigate entry-level models come with Virtual Switch configured by default. This feature allows simple management of firewalls for new users and reduces the number of networks you create by grouping multiple physical interfaces into one logical group. In this video, we will learn how Virtual Switch works and how to remove interfaces from Virtual Switch interface. We will use our on-premises 40 Wi-Fi device, which comes with Virtual Switch configured by default. Although this device have 10 different interfaces, we only see DMZ port WAN 1 and WAN 2 in the list, whereas ports internal 1 through internal 7 are nowhere in the list. And that's because they are added to a virtual switch. So to get to it, we need to expand the software switch interface labeled LAN, and inside of that we see in the members interfaces a generic internal interface. But there is no interface called just internal. However, this refers to a virtual interface that groups our 7 interfaces, internal 1 through internal 7, and the major advantage with this setup is that all 7 interfaces will have one single DHCP server serving them all, and all 7 interfaces will live in the same network. Therefore, they do not need firewall policies to talk to each other, as they are considered a trusted network. For example, if a client is connected to internal 1 port and wants to talk to another client on internal 3 port, communication is accepted automatically, since they live in the same layer 3 domain 192.168.1.0/24. Take for example, this PC has an IP address from this DHCP server, which is 192.168.1.111. For the firewall policy, we allowed internet access to all 7 internal interfaces directly by choosing the virtual switch interface as the source, which made it more simpler. And also, if we change the DHCP monitor on our virtual interface, we will see all kinds of client and we have zero idea which interface they are physically located. It shows LAN for all of them. So the advantage we are getting is all clients live in one logical interface that is simpler to use for policies and management and other configuration as well. And all interfaces have IPs from the same network 192.168.1.0/24. But what if we want to change the setup and use different layer 3 segments per each interface like a normal router? Or what if we want to isolate clients connected to internal ports and control them with a firewall policy similar to internet access? We can do that using CLI, and the command will be config system virtual switch. Under this, we can enter the command show to see how is it structured. We can see our internal interface with our 7 internal interfaces inside of it as members. So we need to edit internal first. This is our interface name, and then we write config port so we can edit the members. And from here we can delete any membership by writing delete and then the interface name. It's highly recommended we remove only few interfaces at a time, since we need to make some adjustment and modification to our policies and IPs. We can start by deleting internal 4 port. And once we get to our interfaces again, we see we freed up internal 4 port, and it's now showing separately in the interface menu along with the WAN ports and the DMZ port. Once the port is free, we can configure it like any other interface, and you can't assign it an IP address from the 192.168.1.0/24 any longer, as it will cause a conflict. Let's give it a unique network 10.10.100.1/24. And we also allow Bing access so we can verify connectivity. And we also need to enable DHCP server for this interface so that our clients in this network are able to get IP addresses and join our network. DHCP IPs will start at the first available IP in the subnet, which is 10.10.100.2. If we want, we can leave a small gap in the beginning or the end of our subnet for static IP association we might need in the future. In this case, I want the DHCP IPs to start at 10.10.100.20, and that will leave us a small space of 18 free IPs so that we can assign them statically if we need to. Finally, let's add an alias to our board so we can document what it is used for. In this case, we will label internal 4 board as Wi-Fi, then save our config. Now our internal 4 board has a unique alias and unique layer 3 network with Bing enabled. So let's try to Bing this interface using the IP address 10.10.100.1, and we will not be able to Bing this interface at all. This is because we removed internal 4 board from our virtual switch, and now we need a firewall policy to allow this communication before we can Bing. So let's create a simple Bing policy for our LAN interface where the PC is residing, to internal 4 interface where the IP address we are trying to Bing residing. And for the source, we will open it to our internal LAN 192.168.1.0/24. For the destination network, it will be our new Wi-Fi network 10.10.100.0/24. We don't need NAT for this policy, so we can go ahead and save our new policy. And if we check our Bing, it will start working. Also, if we check our DHCP monitor, we will start seeing our Wi-Fi clients getting different DHCP IP addresses from our new network, like 10.10.100.20. And this Wi-Fi client will not be able to talk to any internal device without a firewall policy. But we also need to modify our internet policy to allow the new internal 4 interface users to access the internet. Since now they are separate from our virtual interface, they lost their internet access to. So we will need to add internal 4 interface to our internet policy. And to make sure our internet policy is tightened for security, we will just specify the source IPs for both networks in the source field. Our internal network 192.168.1.0/24 and our Wi-Fi network 10.10.100.0/24. And once we save, we fully restored internet access to our Wi-Fi clients. Now let's try a more challenging situation by removing the actual board we are physically connected to from this PC to the firewall, which is internal 2. In this case, if we delete internal 2, we will lose everything immediately. As this separated board will not have the DHCP server, it's not part of the internet access policy, and we are not even able to access our firewall management. So we can save ourselves in this situation by either having console access to the firewall, so we have to be in the same physical location as the firewall is, or remotely using a terminal server connected to the firewall, or we can temporarily move our PC to another internal board that is still part of the virtual switch to finish our internal 2 board configuration first. So let's move our PC cable from internal 2 to internal 6 temporarily, and this allows us to go back to the network and access the firewall management again. Under internal 2 board, we will allow Bing access first, And then we need to set up another unique layer 3 network for clients. Let's choose 172.20.0.1/24 and also enable DHCP server so that our group of PCs can get IP address in the new network. And finally, let's also leave some IPs for static management in case we need them. Give our interface an alias PC, and finally we can save our internal to port config. Now all we need to do is modify our policy to allow the newly separated internal to port access to the internet by adding it to our internet policy source interfaces and adding the new layer 3 network address to our source addresses field as well. But this is not all of it. We have to think of how we will manage our firewall if we are connected to the internal to port. As we see, we have not given HTTPS or SSH permission on internal to port. Therefore, we can either enable it first, or we can still manage our firewall through the 192.168.1.99, which is the LAN interface. And to do that, we have to create a policy to allow the communication coming from our internal to port and also internal 4 in case we are on Wi-Fi, and going to the LAN port as a destination interface. We will make sure that only our PC subnet and Wi-Fi subnet can have access to this 192.168.1.0/24 on both HTTPS and SSH ports. We also have to keep in mind if we change our firewall management HTTPS port, like in our case we are using port 8443, we should open that specific management port and not the default 443 port. We don't need NAT in here either, so we can just disable it and save our new firewall management policy. And now we are ready to switch our PC back to internal to interface. Once the PC gets connected to the original interface again, we see now that we have an IP address from the internal to DHCP pool, which is 172.20.0.20. Then we can relog into the firewall and verify our internal to port is up and working as before. Also, our DHCP monitor will show a lot of diversity with IPs now between our 3 different layer 3 networks on internal interface, PC interface, and Wi-Fi interface. You can repeat the same process for any interfaces you need to separate from the virtual switch, and if you change your mind, you can also add any interface back to the virtual switch after removing any dependencies for these interfaces. And that's how you manage Fortigate Virtual Switch. Thank you for watching.